Hello and welcome, guys. Today we will look at the topic ocean acidification. As you can see on your screen, there are 5 questions that you can attempt, and I will tell you the answer at the end of the lecture, and you will be able to solve them after watching the lecture. Now, what are the reasons for ocean acidification? See, two main reasons are acid rain and eutrophication. We will understand these two issues separately later on. For now, look at the pH scale. At the 7, we consider it as neutral. Okay, when we go beyond 7, it becomes basic, and if we go below 7, that is acidic. Now the pH of ocean is considered to be 8. That means oceans are basic. And remember one thing, that oceans will never turn fully acidic. Okay, they can just reduce from 8 to say 7 point something, but they will never turn acidic fully. Now looking at the reaction, we know that ocean have carbon dioxide dissolved in it. So CO2 reacts with H2O and it forms H2CO3, that is carbonic acid. Now this carbonic acid is weak, unstable, therefore it breaks down into H plus ion and HCO3 minus. This HCO3 minus is bicarbonate, which further dissolves itself into H plus and CO3 minus 2. This CO3 minus 2 is carbonate, and this carbonate is very essential for shell formation. Now this carbonate will further react with CO2 and H2O and lead to formation of 2HCO3 minus, that is bicarbonate. Before we move further, let me clear you two terms, that is calcite and aragonite. Calcite are hard shell organism whose shell doesn't dissolve with rise in acidity of ocean, but aragonite, their shell are comparatively weak and they dissolve when there is rise in acidity of ocean. Is it clear? So, in a nutshell, if there is rise in acidity level of the oceans, these carbonate, that is CO3 minus 2, will convert into bicarbonate. Okay, and since there will be less carbonate, so the shell formation for the organism will be more difficult. Is it clear till now? Now coming back to the acidity of the ocean, when there is increase in concentration of H plus ion, we will say that the ocean is turning more acidic, and when there is increase in concentration of OH minus, we will say that ocean is increasing basic. Now look at this diagram. Here you can see that with the increasing depth in the ocean, we come across 3 layers. First is saturation horizon, second is lysocline, and third is CCD, that is carbon compensation depth. Okay, so what happens is, if we look at the upper layer of the ocean, we see that there is high concentration of CaCO3. Okay, that means there are lot of carbonate. Okay, so formation of shell for the organism will be more easy in this layer. Okay, but when we go further down, then there comes a level called as saturation horizon, below which the carbonate dissolve rapidly. Okay, so you can say that the layer above saturation horizon is oversaturated, whereas the layer below saturation horizon is undersaturated. Okay, so remember what is saturation horizon. It is a layer above which the water is oversaturated and below water is undersaturated. Alright. Now next is lysocline. In lysocline, this is a layer from which the dissolution of carbonate increase at a rapid pace. Okay, below which you will hardly find the carbonates. Okay, so what do you think? The formation of shell for organism will be easier at a saturation horizon or lysocline? Okay, obviously it will be little bit easy at saturation horizon, but till we come down to lysocline, it will become more and more difficult. Okay, then the last layer is carbon compensation depth. Here there is complete dissolution of carbon. Okay, hope you're clear with all these three terms. And let me tell you one more concept, that saturation horizon shift upward due to ocean acidification. Now think why this will happen. Because due to ocean acidification, the carbonate is dissolving, right? Now earlier the carbonate were available till more depth, right? But now they are dissolving due to rise in acidity of the ocean. So this saturation horizon will shift upward. That means the range where it is easy to form carbonate will lessen. Okay, it will decrease. So all these saturation horizon, lysocline, CCD, they will shift upward with rise in acidity of the ocean. Is it clear? Now you can attempt all the 5 questions that we have shown you at the start of the lecture.